Hi everyone. Today we are going to study the system development life cycle, which is also known as SDLC, which is a very important topic in system analysis and design. Basically, you can say that the entire system analysis and design revolves around your system development life cycle. Now, as the name it says, system development life cycle, so basically it describes the life cycle of the system development. The success of any system depends upon the approach of building. Whatever would be the success of the system, it would depend upon what approach was taken towards building that system. So if this development approach is right, the system will work successfully. If the development approach towards the system, towards building the system is right, it is quite obvious that the system will work successfully. System development life cycle, which is also known as SDLC, is a standard methodology for the development of information system. Any information system you take, whenever you are developing any information system, SDLC or the system development life cycle is a kind of benchmark or standard methodology. It's a standard methodology that is used throughout the world for the development of information systems. So whenever you have to develop an information system, SDLC is referred so that you can know what should be the phases of development of a system, basically the information system. It mainly consists of 4 phases. Now, if we talk about these phases or stages of SDLC or the system development life cycle, it has 4 phases. So these 4 major phases are system analysis, system design, system construction and implementation, and system support. See, when I say system analysis, that means analyzing the system. First of all, finding out why are you building the system? Why do you want to develop the system? What are the requirements from the system? So these all things are included in the system analysis. Then system design comes once the analysis of the system has been done. You know the objective of the system. You start designing it. Before actually developing the system, you first design the system. Just like before constructing your house, you get a blueprint of the house prepared, which helps you determine how your house will look or where in which areas which particular rooms will be. So similarly, system design does that kind of a task, that before actually implementing the system, you design it first on papers. The third step is system construction and implementation. Once the design has been done, next you can proceed with the construction of the system and implementation of the system. Construction is building it, and implementing it is basically making it into use. Then comes system support. When I say system support, that means supporting the system. How do you support the system? By continuously maintaining it. So maintenance comes under your system support. System has been developed once, but it needs to be maintained throughout its life. So there comes your system support. So these are the 4 important phases in any system development life cycle. That is the system analysis, system design, system construction and implementation, and finally your system support, because you need to support the system throughout its life cycle. Now, if you talk of traditional SDLCs which were used earlier, they were strictly sequential. The developers first complete the previous phase, then start the next phase. So they were strictly sequential. When I say strictly sequential, that means a sequence was strictly followed as to which phase will be completed first and which phase will be proceeded later on. It is not like you do one phase earlier, phase 1 is done first and phase 3 can be done after phase 1 and phase 2 will be done later. No, if phase 1 has to be done first and phase 2 has to be done later, then phase 1 only will be done first and then will come phase 2 and phase 3. It's not like you can do phase 2 1 and first. It's not like that you can do phase 2 first and then you can do phase 1. No, the development of the system, the phases for the development of the system have to be in a particular sequence, and that sequence is strictly followed. You cannot go out of sequence, right? So this was the case with the traditional SDLCs. You complete the previous phase, only then you can proceed on to the next phase. But in today's scenario, now a new concept has been introduced, and this new concept is of repositories. Repositories, you know, are kind of backup systems wherein you can store the data. So or you can also say repository is like a database wherein you can store collection of data. So this new concept of repository is introduced now in SDLC, and it is known as FAST methodology. So this concept of repository in today's SDLC is known as FAST methodology, and in this FAST methodology, work is done across shared repository. You have a repository, and that repository is shared. It means, now what do you mean by shared repository in a FAST methodology? It means that all the inputs and outputs of phases must be stored in the repository. See, every phase has to be in a particular sequence, no matter if it is a strict sequencing or not, but still it is preferred that when following SDLC, you follow sequence of every phases. Now the input of one phase will, the output of one phase will act as the input of the other phase, right? Say you do system analysis. With the help of system analysis, you find out the requirements of the system. With the help of those requirements, you know what is the objective of the system. And once you identify the objective of the system, then you can design the system accordingly. So basically, identifying the objective of the system is the output that you got from system analysis, and that will be used as an input to system design, because based on those objectives, you will design the system so that you can meet the objectives. So the input of the output of one phase, the output of one phase acts as the input of another phase. So basically, one phase is dependent upon the other phase. That is also one reason why you need to follow the phases in sequence. And the other thing is that every input and output of different phases needs to be stored somewhere. If it is stored somewhere, then in that case there is a little less restriction on sequential SDLC, because those inputs and outputs would be saved. If you do not save the inputs and outputs, then you have to strictly follow sequential SDLC so that you can immediately use that output as the input for the other phase, because you know it will not be saved anywhere. So if you do not use it right now, it will be lost, and then you cannot use it later. So immediately the output of one phase has to be used as the input of another phase. That is why more focus on strict sequencing. But since you have shared repository in the new SDLCs, hence they are less strict in terms of sequencing. Why? Because the inputs and outputs which earlier were supposed to be used immediately, or else you could have lost them, they are now being stored in the repository. So the inputs and outputs of phases must be stored in the repository. And at any time, developers can backtrack to previous phase, and they can also work on two phases simultaneously. So now, since there is no problem of losing the inputs and outputs, you always have your inputs and outputs in the repositories. So the developers have the advantage of backtracking or going back to the previous phase, and they can also work on two phases at the same time because of this shared repository, right? So that is the reason that the current SDLCs are not that strictly sequential, though it is always preferred that a sequence is followed while designing the systems using SDLC. But even if little bit of sequencing here and there is would not matter, because at the end you have all the inputs and outputs from different phases stored in the repositories, and since they are once stored in the repository, they are saved there, and the developers can fetch them any time. So this lets them, this gives them the flexibility to basically backtrack to the previous phases also. It's not that once they have moved on from that phase, they cannot go back to that phase. They can backtrack to previous phases, and they can also work on two phases simultaneously. So this is the advantage of this shared repository, and this method or this new kind of SDLC is also known as your FAST methodology. Why FAST? Because the developers can work on two phases simultaneously at the same time, which fastens the process of system development. Now let's look at the diagrammatically, let's look at various stages of the system development life cycle. The first four stages of the four phases of the system development life cycle that I showed you, that is system analysis, system design, system construction and implementation, system support. These are the major four phases. But in general, if you look at the system development life cycle in detail, these are the various phases of the system development life cycle. So if in exam you are asked about the phases of the system development life cycle, you have to tell all these phases, you have to draw all these phases. So this is a detailed phase diagram of the system development life cycle. So it starts with preliminary investigation. Preliminary investigation is system analysis only. So basically analyzing or investigating this system. See, if you come up with an idea of a system, you should be sure of the fact that why do you need that system? You need that system for certain reasons. So are those reasons really necessary and valid? If they really are necessary, if they are valid, only then you should proceed on to implementing or developing that system. So this is what is done in preliminary investigation, that the system analyst would investigate why do you require this system at first place, right? So this comes in the preliminary investigation. Next is determination of system requirements. So after the preliminary investigations, you would determine what are the requirements from this system. What are the requirements that this system is supposed to fulfill? Once you are clear with the requirements of the system, that means you know what is the objective of the system, and once you know the objective of the system, then you can design the system accordingly to meet those objectives. So after the determination of system requirement comes the phase which is the system design or design of system. See, once a blueprint of the system is ready, that means the design of the system is ready, then you can start implementing the system. And in terms of information system, how do you implement the system? By developing a software for that system. So that means after system design, what do you do? Which phase comes? Development of software. Once the software has been developed, you will need to test it. Before you hand over this information system to the actual client, you need to test it yourself first, whether it is working properly or not, whether it is meeting the required objective or not. So that means after the development of the software, you will do system testing. If everything goes fine with system testing, there are no errors, you hand over this project or the system to the client. But if there are some problems with this system, it is not meeting the required objectives, obviously then you have to make some modifications which will be done in the development of software phase itself. You will go back to this phase, make some changes, and then again you will do system testing. Now this time if everything is okay and there are no errors, finally you will hand over the system to the client. So you keep on going back to the development of software phase until in the software testing phase there are zero errors. Once system testing has been done successfully and there are no errors in the system, you can finally implement and evaluate the system. Implementation and evaluating is basically putting that system or implementing that system on the client's site, on the client's system, and then it can be evaluated there on the client's site. So these are the these are the phases of system development life cycle. 1, 2, 3, 4, 5, 6. In total, there are 4 phases of system development life cycle. So whenever asked about the phases of the system development life cycle, you should be drawing this diagram and you should be explaining these stages in or these phases in detail. For making a successful system, the following principles should be followed, right? If you are really intended at making a system that should be successful, then these principles must be followed. Now, what are these principles? First of all, both customers and developers should be involved for accuracy information. See, customers are basically the clients for whom you are developing the information system. So, and developers are those who will be basically developing the software for the client. So the customer or the client and the developers both should be involved in the accuracy of the information, because the task of the developer is to develop it, but nobody knows it better than the customer or the client that what he wants from the software. So if both of them are involved in it, then only it will be possible for the developer to develop an accurate information system that is according to the customer, right? The second principle is that a problem solving approach should be adopted. Now, a classic problem solving approach says you study and understand the problem and its context. See, there are certain problems to which you need to find the solution, and only that is why you are building the system. There were some problems, you wanted solution for those problems, hence you thought of designing a particular information system which could solve your problems. So that is why a problem solving approach should be adopted. You are developing, you want the information system to be developed to solve certain problems. So that means the first approach towards building a system should be problem solving. How do you have this problem solving approach? So first of all, you should study and understand the problem and its context. You must study what the problem is. Once you've studied, you must understand what that problem is and what is the context of that problem. Once you've studied and understood the problem and its context, it will be easier for you to define the requirements. You know the problem. Obviously, if you know the problem, then you also know what are the requirements from the system, because these are the problems, and hence to solve these problems, these are the requirements from the system. Say, for example, before COVID, there was no concept of online systems. So the ERP systems of the colleges were not focusing on online classes. They were only focusing on uploading the assignments, downloading the assignments, uploading the marks and stuff like that. When came COVID and online classes were introduced, the ERP systems had this problem. Now, what was the problem to develop the ERP systems then? The problem was that these kids could not study offline, so they needed some mechanisms to study online. This was the problem. Now, you understood that this is the problem, so that means what is the requirement from the system? The requirement is to develop a software wherein the teachers can take lectures online. They can be heard and seen at the same time. Their attendance can be marked at the same time. So this was the requirement based on the problem. So if you study and understand the problem and its context properly, then it will be easier for you to define the requirements for that particular system so that you can find the solution. Once that has been done, you have to identify candidate solutions and select the best solution. See, you cannot just choose one solution and start developing it. You have to select candidate solutions. When I say candidate solutions, means multiple solutions which are candidate for becoming the final solution. They are not the final solution. You have to decide out of all those solutions available to you. Say you have come up with 4 or 5 solutions to develop a system. Now, out of those 4 or 5 solutions are the candidate solutions. And out of these 4 or 5 candidate solutions, you will select one solution which will be the best among all. So you identify candidate solutions, and then out of all of those solutions, you select the best solution. Then you design and implement the solution. See, now you know what the solution is. You've studied the problem, you've understood the problem, you've defined the requirements, you've had several candidate solutions. Out of those candidate solutions, you chose the best solution also. So what is left now? Now you have to finally design and implement that solution. You know what the solution is. Now you have to first of all design that solution. How will you come up with that solution? And once the design is ready, you have to implement the solution. Whenever you design a software, you write programs for the software. Basically, what do? You write the algorithms for that software. You dry run that software. So that all would come under design. What would be the template of the ERP system, how it would look, what would be the various menus, what would be the various sub-menus, what would each sub-menu do. All these things come under the design phase, and finally implementing means you start developing the software for that system, so that comes under the implement. So once you have a solution in hand, you can design and implement the solution. After that, observe and evaluate the solution's impact and refine the solution accordingly. This is what comes under your software testing, that you observe and evaluate the solution. Okay, you know what the solution is, you have implemented the solution, so finally you have to do testing also, no, so that there is no problem when you take it to the client side. So you will observe and evaluate the solution's impact. What is the impact of solution, whether it is giving the desired results or not, whether it is meeting the requirements of the system or not. If it is meeting, well and good. If it is not meeting, then you refine the solution accordingly and keep refining it until you have an impact which meets the requirements of the system. The third approach, the third principle that should be followed is phase and activities should be established. Various phases and activities should be established. You should know that this is how the system will be developed. So this should be the phases for the development of the system. 4 phases, 5 phases, 6 phases. In different phases you design the system. Also, according to those phases, the activities will be established. The fourth rule says, for consistent development of a system, some standards should be established. Obviously, it is always desirable in a system that it should be consistent. Consistent means it is same throughout. So the consistent development of a system, some standards should be established. Now these standards are, the first is your documentation standard. It is very important whenever you are doing system analysis and design to develop a system, everything should be documented so that for future reference there is no problem. Even if it is a developer or it is a client, whenever you have to do maintenance of the system, the documentation helps a lot. You can refer to the documentation and know for what problem what should be done in the system. So the documentation standards is a very important standard. It should be an ongoing activity during the system development life cycle. Whatever you are doing, you just document it, you just write it on a piece of paper, you document it well, so that when the system is ready, the client can refer to the document and know what to do with the system, how to use it, what the system will be doing. Similarly, if the maintenance of the system has to be done and some new developer comes, the developer who developed that system leaves and some new developer comes, he has no idea of how that system will be maintained. So the documentation will come in handy at that time also. So everything from the first phase to the last phase of system development life cycle should be documented. Next is your quality standards. Checks should be established at every phase. See, software testing is one thing. That is when you finally develop the software and then you test it. But otherwise, apart from software testing, your quality checks or testing basically should be established at every phase. From the first phase till the 6th phase, at every phase you must do checks or testing. So for ensuring that the output of every phase meets the business and technology expectations. You know, the output of one phase acts as the input of another phase. So basically each phase is interdependent upon another. If you fetch a wrong or inaccurate or inconsistent input to the following phase, then the overall result will not be good. So before actually doing the system testing or the software testing, you must ensure checks at each and every phase individually also, that because if there is any flaw at even a single phase, the final result or the final software will have flaws in it. So it is equally important to check each and every phase so that you can ensure that the output of every phase meets the business and technology expectations. Basically, the automated tools standards is another thing that must be followed. See, as I said, for consistent development of a system, some standards must be established. So the first standard was documentation standard, another was quality standard. The third standard is your automated tool standard. Hardware and software platforms should be finalized for the development of information system. You should not be in any dilemma that which software or which hardware will be used when and where. Hardware and software are two such things that should be finalized, and then you should stick to them for the development of the information system. Then the automated tool standards basically prescribe technology that will be used to develop and maintain information system and to ensure consistency, completeness and quality. When you stick to one particular kind of hardware and one particular kind of software, basically it will prescribe the technology that you will be using throughout to develop and maintain the information system. Developing is one thing and maintaining is another. Development is one time thing, but maintenance is an ongoing thing. So even for maintaining the system, the same hardware or software will be used to maintain the information system. So you basically are kind of prescribing that, okay, this technology will be used throughout from the development till the maintenance of the information system. So it is very important to choose the hardware and software platforms that will be used for the development of the system, and they should be finalized, and then they should be used throughout from the development to the maintenance phase of the information systems. Basically this helps to ensure consistency. The system is same throughout, right? So it helps to ensure consistency. Then there is completeness. The system is complete, and when the system is consistent and complete, obviously it would ensure a good quality system. The fifth standard is that, the fifth rule for the development of a system development life cycle is that the developer of an information system should think about several solutions of a particular problem. See, as I said, out of candidate solutions, you will choose one solid solution or one best solution. But you cannot just jump to one solution. First of all, you need to have several alternatives, right? Even in a day-to-day life, to solve your problems, you think of various solutions of a particular problem, and out of those solutions, you choose the best one. So the similar approach should be followed for the development of information systems also. And it is obviously the developer who is developing the information system. So the developers should think about several solutions. The developer should not focus on just one solution, but think about several solutions of a particular problem. And then every solution should be evaluated. You evaluate each and every solution for the cost effectiveness and risk management, right? Cost effectiveness means finding out how effective in terms of cost that system is, and risk management means how much risk would be managed in using the solution. That means lesser the risk, more effective that solution is. Now, when I said that the solution should be cost effective and it should provide for risk management also. So when I say cost effective, it is defined as the result obtained by striking a balance between the cost of developing and operating an information system and the benefits derived from the system. So basically what you should evaluate the system when you are evaluating the solution, when you are evaluating it for cost effectiveness, that means you are finding out what is the result obtained from this system, and whether the cost of developing this system, the cost of operating this information system is less or more than the benefits. If the benefits outweigh the cost and of developing and operating the information system, if the benefits outweigh, or if the benefits are more than the cost of developing and operating the information system, then that solution is an optimum solution. Other thing is that apart from evaluating the cost effectiveness of a solution, you will evaluate the risk management also of the solution. Both things have to be evaluated. Now, in risk management, evaluation is defined as the process of identifying, evaluating and controlling what might go wrong in a project before it becomes a threat to the successful completion of the project or implementation of the information system. So basically in risk management, you are evaluating and at the same time trying to control that what are all the possibilities in this solution which may go wrong. You will evaluate each and every possibility which can go wrong during the development of the project if you choose this particular solution. And you should also know that if these things go wrong, whether they can be handled or they would become a threat to the successful completion of the project or its implementation of the particular information system. So if you think while evaluating that things that may go wrong can be handled, you can think of choosing that solution. But if you think that things go wrong with the solution, and then at a certain stage those things which went wrong can become a threat to the completion and implementation of the information system, then you would not choose those solutions. So basically you would evaluate the cost effectiveness and risk management of all the solutions, and one such solution in which both the cost effectiveness and risk management are optimum, you will choose that particular solution. Then another principle or another rule is that multiple feasibility checkpoints should be built into system development methodology. Whenever, as I said, every phase should have a checkpoint. The output of every phase should be tested. So this is what I mean by saying multiple feasibility checkpoints should be built into system development methodology. Now, at each feasibility checkpoint, all costs are considered sunk. When I say all costs are considered sunk, that means non-recoverable. So every feasibility checkpoint you consider that these costs would be the cost incurred or involved in the development of this particular phase would be unrecoverable. So the project should be re-evaluated at each checkpoint, not just once, but it should be re-evaluated at each checkpoint to determine if it remains feasible to continue investing time, effort and resources. See, you are not just investing your money, you are investing time for a particular information system. For the development of a particular information system, you are investing efforts of so many people and so many resources go in for the development of that system. So whether all this time, effort and resources are worth, it is worth to put all that time, effort and resources for that system. So this is what you check in the feasibility study, how feasible that system is. It is effort to put all my time, effort and resources into this system. Will it be feasible enough? So this all has to be checked at various phases and rechecked every time. At each checkpoint, the developers should consider the following options. When you are checking the information system at various phases, that means that each checkpoint, what should the developers consider? These are the options that the developers should consider. First of all, you should cancel the project if it is no longer feasible. You check the feasibility, you recheck the feasibility, and still if you find if it is not feasible to put in that much amount of time, effort and resources, the result that you would get after implementing the system and operating this information system are not worth the time, effort and resources that you are putting in, then at that very moment you must cancel the project. Okay, if you do not cancel the project at this particular stage, you find it is feasible enough, then you must re-evaluate and adjust the cost and schedule if project scope is to be increased. If there are some changes that need to be done in the project, if you think the scope of the project needs to be increased, then you must re-evaluate that project. And accordingly, you should adjust the cost and schedule. You will adjust the cost and schedule. That means you will basically either put in more amount of money and time, or you will try to fulfill all those increased scope requirements of the project with the same amount of cost and more amount of time. So you have to adjust the things accordingly. You may put in more money and more time, or you may put in less the same amount of money but with more time. So you have to adjust the cost and schedule if the project scope is to be increased. Then after that, at each checkpoint, the developer should also consider this particular option, that he should reduce the scope if project budget and schedule are frozen and not sufficient to cover all the project objectives, right? Sometimes the cost and time are frozen. Frozen means the client is stuck on the fact that he cannot invest more money and time in this project. He cannot afford money more than this. He cannot afford time more than this. He wants this particular project to be completed within this particular span of time. He cannot afford to increase the span of the project whatsoever. So if that is the case, that means the project budget and schedule are frozen, then you must reduce the scope of that particular project or information system. If the budget and schedule are frozen, that means they cannot be increased and not sufficient to cover all the project objectives. See, if the budget and schedule are frozen, you have constraint on the budget and time schedule of the project, then obviously it is possible that it may not be possible to achieve or cover all the objectives of the project. If you are not able to achieve all the objectives of the project, that means the scope of the project cannot go beyond a certain limit. You have to reduce the scope of that project in that case. So if you think that the budget and schedule are frozen and the client is adamant on the fact that he cannot increase the budget and schedule of the project, so it is very obvious that if you cannot increase the budget and schedule, you cannot increase the objectives also of the project. So that means in that case you will have to reduce the objectives. That means the scope of the project will be reduced. So there and then you should reduce the scope of the project in that case. So these are the 3 rules that should be followed at each checkpoint, or 3 options that should be considered at each checkpoint. Now the last rule for developing a system development life cycle is that you should divide and conquer. You should use the divide and conquer approach. That is the only way of making a complex problem easier. We have studied modular design, modules, and even computer networks. That is the basic reason why we divide a system into subsystems or modules, so that the complex problem becomes easier. In this approach, the larger problem, that means the system, is divided into smaller problems, that is the subsystems. Once we divide the system into subsystems, it is easier to target the problems of the subsystems than to target the problems of the entire system as a whole. And the last rule that should be followed, or the last standard that should be followed for the development of a system using various phases of SDLC, is that for development of a successful system should be designed for growth and change, right? You know things are not fixed. Things change with time, so does an information system. So when you are developing an information system, keep in mind after 3, 4, 5 years, technology will change, things will change, requirement from the system will change. So the developers should develop the system keeping in mind that this system is designed for growth and change. With time, when the system needs to grow and change, it should be possible in the maintenance phase. When the system is implemented, it enters the operation and support stage of life cycle. Finally, when you are implementing the system, it is entering the operation stage wherein you will be finally operating the system, and support stage wherein you will be continuously maintaining the system with the changing requirements of time and environment. So when finally you implement the system, it enters the operation and support stage of your life cycle, or the system development life cycle. Now during this stage, developers encounter the need for changes that range from correcting simple mistakes to redesigning the system. During the operation and support stage, the developers will encounter the need, or will feel the need for changes in the system, because when you are maintaining, that means continuously you are doing some of the other changes. These changes may be little changes, small changes like correcting simple mistakes, or some very big changes like redesigning the entire system, so that you can accommodate the changing technology, because the technology would obviously change with time, and in order to accommodate those changes in technology, you would need to do changes which would range from small changes like correcting simple mistakes to some big changes like redesigning the entire system, so that you can make modifications to support changing user requirements. With time, when these user requirements change, you can modify the system using these changes.